Alright, welcome to our video where we're going to talk about prime numbers. This is the fourth problem in our programming competition this year, and it just asks us to find all of the prime numbers between two given numbers in a range. So the problem's pretty straightforward. This was one of the more successful problems. More teams solved this than some of the other ones. So, just as I have with the others, I'm going to start out by making a scanner object, and I will call it KB, short for keyboard. My Eclipse is hanging on me. Alright, there we go. So, there we go. We got a scanner, and the first value that we're going to read in is the number of cases. And just as we did a couple of videos ago, we're going to use a little bit of a cheesy for loop to control this. Going to loop while cases are greater than 0 and subtract off a case every time. So we don't need anything in this first spot just because we have that value. We got it from the keyboard. Alright, so the way the problem asks us to work is to read in two variables, the lower bound and the upper bound, and it describes them as A and B. So that's how I'll read them in as well. A is, of course, the lower bound, and B is the upper bound. So, since we don't need to be too concerned with efficiency in this case, all we really need to do is loop from the lower bound up until the upper bound and check if the number is prime. And if the number is prime, we'll just print it out, and otherwise we will just continue. Since the problem asks us to not be inclusive, we're going to start our loop at 1 more than A plus 1, and we'll loop up until B, not touching B, because again, we're not inclusive on our upper bound. And here all we have to do is just check if the number I is prime. So I will write a helper method to do that in just a second. For now, we'll just pretend that that's going to work. And we will print out the value of I and print out a space after that. All right, so I think that's all we should really need to do. Oh, excuse me. We'll need one more line just after each test case. So that way, after each iteration is done, we're just going to print one line at the end. All right, so all that's left to do is really just implement this is prime, which is going to take in a single value, I, and it's just going to return whether or not that value is a prime number. So I'm going to make it a private method, and I'm going to make it static just because it's called from our main method, and it's going to return a Boolean, which it would be true if the number n is prime and false if the number n is not prime. So the way we've defined, or the way mathematicians have defined whether a number is prime is, first of all, if that value is less than 2, it is not a prime number. So in this case, we can just return false. Otherwise, we're going to need to loop from the lower bound up until n and see if any number is divisible by n. And if it is the case that a number is divisible by n, then that number is not prime. So I'm going to make a Boolean variable. I'll call it found factor. Set it to false initially. So if at any point we find a factor, meaning the number is not prime, we'll just switch that to true. And like I said, we're going to loop starting at 2, going up until the number n, and we'll increase f every time. So f is just kind of representing the factor that we're looking at in this case. And all we have to do to see if the number is divisible by n is just do this modulus operation, just like we did in the ducks problem. So if we just check n mod f, this is the modulus operator, this will tell us if the division of n divided by f returns the remainder 0. If that happened, well, that means we found a factor. That means that f is evenly divisible by n. So we're going to set this found factor variable to true, and we'll just break, because once we found one factor, we know that that number is not prime. So at this point, we can just return the opposite of found factor. All this does really, it will return true if found factor is false, meaning that the number is prime if we didn't find a factor, and it will return false if found factor is true, which is what we'd expect. So now our code up here compiles. Let's run this one time. Save that. And we'll do 3 test cases. Let's try in the range of 1 to 25. Those look like all of our prime numbers in that range. Let's try, I don't know, 3 to 17. Those are our prime numbers in that range. And let's try one more, a little bit of a wider range. Let's go 0 to 100, just like the song by Drake. And it looks like there are a lot of prime numbers in that range. But yep, those all look correct. That looks like the output that we would about be expecting. There's one space at the end, but that's all right. So yeah, that's pretty much all there is to this program. All we really have to do is just loop for each case, loop up from A until B, check if the value is prime, and if it is, we just print it out. So thanks for joining us in this one. Feel free to leave any comments below if you have questions. Otherwise, feel free to join us in our next video when we talk about circles.